Hello world! Welcome back to another CTFlearn challenge video. In this video, we'll be walking through the reverse engineering challenge, Riyadh. Let's get into it. Another entry-level reversing challenge. If you are new to reversing, you probably want to try my Reykjavik challenge before attempting this challenge. Good luck! The flag is hidden inside the Riyadh program. Solve the challenge, get the flag, and I have included the encrypted sources used to create the challenge in the riyadh.zip file. If you do the work of solving the challenge, I'm providing the challenge source code, C++ and Python, if you are interested in studying the sources after solving the challenge. I think this is a great way to improve your reversing skills when learning. Please don't share the sources or flag after you solve the challenge. Well, we're going to ignore that last statement as we are here to learn, but they give us a riyadh.zip file as the challenge states. And the only thing we're going to be interested in this riyadh.zip file is the Riyadh program, because the other files are just for learning and documentation purposes. So that being the case, let's run file on Riyadh. We can see that it's a 64-bit ELF. Let's go ahead and try running it. We can see that it prints a welcome message, some compile options here, and then a usage guide on how to actually run it. It looks like we need to run it with an argument that represents our flag or what we think the flag is. So let's try doing that. And we'll just use CTFlearn test as our test flag. It says you entered the wrong flag. I'm assuming if you enter the right flag, it'll say you entered the right flag. So let's pop this open in Cutter. As you can see on the left, we have a main function. Let's go ahead and open that in the decompiler panel. We can see that there's a message 1 being loaded here and printed to the screen with puts. And message 1 is probably the welcome message because following that is our compile options right here. And then there's an if condition checking the number of arguments that we have. argc represents the argument count when we run a program. However, argc will always be 1 because it counts the actual program itself that's being executed as an argument. So when argc is 1, that's when it prints out this help guide, because that's when we ran Riyadh without any arguments. And then it'll go to this else condition if we have an actual argument following it, as we do here, and then it prints out the wrong flag. Now, it looks like all these messages are represented by these message functions that we see here. So we don't actually know which is which unless it's in plain text, or we just follow the coding logic. However, we can surmise that message 1 is the welcome message, and message 2 is the help guide, based on our testing of the executable itself prior to opening it up in Cutter. As we can see in the else condition, there's a blaring CTFlearn hidden flag function here. Let's double click that. We can see that it's an empty function. It just doesn't return anything. So we'll go back to the main function. Maybe this is the author's way of saying, hey, look here to see where the flag is. We can see our argument being stored in arg1. So our test flag is going to be stored in arg1 here. And then message 3 is going to be loaded. And then our arg1 is going to be compared to something that's stored in this buffer here. And if ivar4, or if the strcmp function returns true, essentially, 0 means that the two strings that strcmp is comparing match, then it's going to print message 4 right here. That being the case, we need to figure out what this buffer is, because clearly that's what's being compared to our argument to distinguish whether we actually got the right flag or not. Now, we can use Radari to do this, but I'm actually going to do this in GDB because I find it to be way simpler. So let's go ahead and fire up GDB on our Riyadh program, and we'll disassemble the main function. And we'll scroll up to where we find the relevant code that we were looking at. We can see the CTFlearn hidden flag function right here. We can see message 3 right here, and we can see our strcmp right here. Now, we want to figure out what's in that buffer, and luckily I have GEF installed as a wrapper over my GDB program, so we get extra data. So if there is something in that buffer variable, or whatever GDB identifies it as, we will be able to see it in plain text. We just got to figure out where we want to set our breakpoint. And I'm thinking that we just set our breakpoint on the strcmp function because it's already going to have whatever's being compared to our input loaded into the function by the time it calls it. And that's probably what's being done here with this RDI-RBP and RSI-R13. And GEF will be able to print out what these registers are at the time of this strcmp function call. So that being the case, let's go ahead and set a breakpoint on this address. We'll do breakpoint at that, like so. And we'll go ahead and run our program, and we'll put in our test flag as an argument. And we got a cannot insert breakpoint 1, cannot access memory at address 0x1160. This happens sometimes, and I don't know why it does this, but we can actually mitigate this by referencing where this address is from the main function address. So what we need to do is come back up and look at this value right here, plus 96. And we will do break at main plus 96, like so. And then we'll do run again. We actually probably need to quit out and relaunch it since it's got that breakpoint there. And I kind of forgot how to remove breakpoints in GDB. So let's try that again. Break star main plus 96, like so. Then we'll run it with our test flag. And we'll actually do subscribe this time because I want y'all to subscribe. And right here, we can see that RDI has our actual flag and RSI has our input flag. And it looks like those are what are being compared to each other. So our flag ends up being reversing is easy. So we'll copy that, paste it in, and submit. Well, that's all. We got an incorrect flag. Is it possible that this is a false flag? Let's go ahead and copy this flag. And we'll quit out of our GDB, and let's actually try running Riyadh with that flag that we uncovered. It gives us a message, you found the false flag. It's not that easy, dude. Okay, so we were a bit premature in our assessment here. So let's go back to Cutter, and let's see what else we can dig up. We see that there's an else block following whether our strcmp function passes here. So we got message 4, and message 4 must have been the false flag message, meaning that our flag is probably embedded somewhere within this else block. That being the case, let's go ahead and analyze the else block. We can see that ivar6 is storing the length of argument 1, and it's comparing our ivar6 or our length to 0x1e. Now I'll save you the time of actually having to convert that to decimal. 0x1e is decimal for 30. So if our flag is a length of 30, then it's going to execute this next block of code. And right here, we can see that there's a message 5. Now, we don't know what this message is actually going to print out, but what we do know is that there's a puvar5 variable being assigned here, and that quite possibly might have our flag inside of it. So we need to figure out what that puvar5 is going to be. Going back here, let's go ahead and run GDB on our Riyadh program one more time. And we'll disassemble main again. Let's scroll up to where we actually have that code that we were looking at in Cutter. We can see that there's strlen right here. And we can see that this is where it's probably comparing the length of our input to 30. And then it says jump if not equal to somewhere else. So we do want them to equal. And then here's where message 5 is. So if this is message 5, then let's go ahead and put a breakpoint at the instruction following message 5 and see if there's anything in our RBP, RDI, or any other registers that could be of interest to us. Hopefully the flag. So let's go ahead and grab this instruction. And remember, we don't actually want to grab the function call itself this time because we want to see what it returned. So we're going to grab one instruction afterwards, and we're going to want to grab this plus 151 because grabbing the whole address didn't work for us. It errored out. So we'll do breakpoint star main plus 151 like so. Then we'll run it with a flag that's 30 characters. That way we can enter that next if condition. So we need CTFlearn, which is 8 characters, 9 characters, closing curly braces 10 characters. We need 20 A's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 like so. And let's execute that. It did properly stop at our breakpoint, and if we scroll up, we can actually see a new flag being stored in our RBP register. Mazmac Fortress 1865 is hopefully this time our actual flag. So we'll copy that, paste it in place of our previous false flag, and submit. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.